Good day, people. This is EA Lego Academy. Welcome back. So now today I will be redoing the conditional statement tutorial because I got a few complaints from my subscribers that the last video was not audible enough. So I will be doing my best to explain properly in this tutorial conditional statement. Now to make things more um, to make this course flow properly for proper comprehension, I have decided to compile my notes for the entire course, that is for the entire tutorial series that I will be doing over the course of other videos. So I decided to compile everything into a single note. So today we are going to be starting with conditional statements, what they are. So I will be breaking this down. I will be doing the explanation before we get into writing code. All right, so we're going to start with conditional statements, what they are. So now, as you can see, this is the note, the right top of its definition. So I said conditional statement, these, so the proper thing is supposed to be these, not this. So these are statements that are either true or false. They determine whether a program gets executed or not. So conditional statements, a succinct definition of them is that they are statements that are either true or false, and they determine if a program would get run or not. Now, if they are true, then it means that the program would get executed. But if we have a false conditional statement, it simply means that that program would not get executed. Now, to further break down how we can use conditional statements, we have the truth table in order for us to be able to use them accurately and properly. Right, the truth table. So this is a table that allows us to compare true and false values. There's supposed to be values here. So this is a table that allows us to compare true and false values to get either a true or a false result. So the summary of what this definition is trying to say is that it's a table that allows us to compare Boolean values to get a Boolean result. That's it. It allows us to compare Boolean values. So Boolean values are either true or false. So they are either true or false, and we will be looking at them properly later on in this tutorial series. Now, mind you, now these values that we're comparing together to get either a true and a false result, they can be more than two. They can be three, they can be four, they can be as many as you want. They can be as many as possible. Now, for the sake of simplicity, I will be working with just two values. Two values. Now so let's look at them in the light of variables and values. Now let's say I have two variables, P and Q. And let's say both variables will be assigned two values each at different intervals. Now let's take the first interval. Now you can see this table I drew here for you. Now this table gives us the explanation of this definition. Now the first columns you can see for P and Q, they tell us or they show us the possible arrangement of matching P and Q values together. That's what they show. They show us the possible arrangement for us to be able to match or pair P and Q values together. So all these values you see here, the values you see under the column of P and the values you see under the columns of Q, they are the possible arrangement of matching the pair, that is of matching each value from P and Q together. Now let's see how we came about this arrangement. Now you discover that you can see two values matching each other here, true. Now the first one says that if the value of P is true at this point in time and the value of Q is true at this point in time, it means that we can match both of them together, true. That's why you can see in the first row of the first two columns in our table, we have true and true. Now, we always start from P, as that is the left-hand side. Since it was P I wrote first. If I wrote Q first, then it means that I'm going to start from Q. But because I wrote P first, I'm starting from P. Now, since I'm starting from P matches here to Q, the first value of Q. That's why we have true true. Now, since I'm still starting from P, the next pair, the next match that we are going to have is true matching down here to false. That's why we have true false. Now, after we are done with the first pair, that is using the first value of P matching to the two values of Q, the next possible arrangement we are going to start from is the false value of P. Remember, we are starting from P. So starting from P, matching this false value to this true, we have false true. That's why you can see we have false true. And then the last possible arrangement is false false. That's why you can see false false down here. Now, before we see how we got all these results, now remember the definition of the truth table is that it allows us to compare Boolean values or true and false values together to get either a true or a false result or to get a Boolean result. Now, these columns here, the column of the P and Q, P or Q, operator.xor, PQ, not P, they are the result of matching all these values together at the first two columns. So when I match these two values in the first columns of P and Q, I get this. So before we can see how we got this, I want to give you some other definitions so that it will be clear to you, so that the explanation will make sense. Now let's look at logical operators, what they actually are. Now, these are operators that allow us to compare two or more true or false values together to get either a true or a false result. Below are the following type of logical operators. Now you can see a similarity here with the definition of logical operators with that of the truth table. It's because the truth table allows us to be able to compare Boolean values to get Boolean results, and logical operators, the end product of logical operators are Boolean results stemming from the comparison of Boolean values. So their definitions are one and the same, because the the sole purpose of creating the truth table is to be able to see the result when we use logical operators. So we can say that the truth table implies logical operators, not explicitly, but it implies it. Now let's look at the various types of logical operators. So I'm going to start with the AND operator. So we said this operator states that we get a true Boolean result only when both Boolean values are true alone. So I'll explain that before I go back to the table. Now if I have two Boolean values, let's say true and true, because both of them are true, I'm going to get a true result. If I have three Boolean values, let's say true, and they are all true, 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 I'm going to get a true result. Now, if I have four Boolean values and maybe three of them are true and the last one is false, I'm going to get a false result from the definition of the AND. The AND tells us that if at all we are trying or we want to get a Boolean result, we must ensure that the values that we are comparing together are all true. Now, it doesn't really matter how many Boolean values you are trying to compare together. If you have a false value amongst them, and let's say they are all, let's say the majority of them are true, and maybe we just have a single false value, it nullifies everything to false. Everything becomes false. That's what we're trying to say. Everything becomes false. So the AND operator states that in order for you to have a true Boolean result, all your Boolean values must be true. All right, now let's come back to the table to see if that definition applies here. Now, you can see that from what I said, we are going to be starting with two Boolean values. You can increase the number of Boolean values you are trying to compare together, but for a start, we're starting with two. Now, you can see that the first two Boolean values here are true, true. That's why I got a true result. The next Boolean values are true, false. That's why I have a false result, because according to the AND definition, the definition of the AND logical operator, it tells us that the moment we have a false value in our comparison, we're going to get of false Boolean result. Now you can see that here also I have false true because I have false. That's why I get false as the result. Now the last one, I don't even have any true value there. That's why you can see that comparing two false values together gives me a false result. I hope that makes a lot of sense. I'm trying to make sure that you guys get exactly what I'm trying to explain. All right, so before we comment, if you are already enjoying this video, please like, share, and subscribe, as it would encourage me to be able to make more videos like this. It doesn't take anything from you, just like, share, subscribe. Thank you. All right, so the next logical operator we want to look at is the OR operator. So now the definition states that this operator states that we get a true result if we have at least one true Boolean value. Again, I'll do a brief explanation. So what this simply means is that it doesn't matter how many Boolean values I have. If I have maybe like 9 false values and I have a single true value there, just because I have a single true value there, it automatically makes everything, the result, true. So the OR logical operator, we can say, is the opposite of the AND logical operator. The OR operator tells us that the moment we have a true value amongst our values, it means that we are going to have a true result. I hope that makes sense. So if you scroll back up to your truth table, you will discover that the first comparison here, true, true, gives me a true result. The next comparison, true, false, gives me a true result because I have a true value there. It doesn't matter how many false values I have. As long as I have a true value, I would get a true result. Now the next one, false and true, is a true value there. So I will have a true result. And the last one, there's no true value there. That's why I have a false result. Now let's continue. So now the next one we have is the operator.xor operator. In some programming languages, we call it bitwise XOR, or the bitwise operator. So now let's define. So this operator states that we get a true result when both Boolean values are different, and we get a false result when both values are the same. What does this mean? What this simply means is that it doesn't matter what you have. If I have three values, three Boolean values, and maybe everything is true, provided that they are all the same, I'm going to get a false result. And if I have three Boolean values again and they are all false, because they are all the same, I'm still going to get a false result. So the operator tells us that if all your Boolean values are the same, regardless of whatever Boolean value they fall under, be it true or false, doesn't matter. If everything is the same, you're going to have a false result. But the moment they deviate from another, or the moment one of them deviates from the other, we're going to have a true result. So let's say I have three Boolean values and two are false, but one is true. I will get a true result as long as they are not all the same. That's just what this operator is trying to say. Now let's go back to the table and let us try to see if that definition does apply here or if it makes a lot of sense here. Now you can see that I have two true Boolean values that I'm comparing together, and you can see the result is false. Why? Because they are the same. Now the next one, true, false, they are different. So because they are different, they are not the same, we have a true result. The next one also, false, true, they are also different, we have the true result. And then the last one, they are the same, so we have a false result. All right, now let's look at the in operator. Now you would notice that the in operator, although it's a logical operator, we did not use it in the truth table. The reason being this: we cannot use it to compare two values together. We only use it to confirm if an element is contained in a data structure. We would explain more on this. So I said this operator allows us to check if a value is inside a list. This operator allows us to check if a value is inside a list. So we're going to make use of it properly later on. So it's not in the truth table. That's why I did not refer back there. So let's look at the not operator. So this operator allows us to get the opposite of the referred Boolean value. So what does this mean? It means that whichever Boolean value you are referring to or you are talking about at that point in time, it would allow us to get its opposite. And let's go back to the truth table and let's see. Now, I decided to choose not P. I could have as well said not Q or not P and Q or not P or Q or not operator.x or PQ. Now, like I said, this truth table can be expanded to be more than this as long as you are using these four as a basic principle. Now, since I'm saying not P, now the value of P at this point in time is true. So the opposite of P at this point is going to be false. Also here, the value of P at this point in time is true. The opposite of P here is false as well. Likewise, the opposite of this, true. And the last one, true. I hope that makes sense. All right. So now this now brings us down to comparison operators. Now, why are we doing all these definitions? It's so that you will be able to understand when we start applying logical operators to our code. It will become intuitive to you. You'll be able to understand what we are talking about. So let's look at comparison operators. So these operators allow us to compare two values to get a Boolean result. Now, the difference between comparison operators and logical operators is that for logical operators, you are comparing multiple Boolean values to get a Boolean result. For comparison operators rather, you are comparing two values. Now, these two values you are comparing together, they are not Boolean values. They can be numerical values, they could be string values, text, characters. So you are comparing them together, but the result you are trying to get is always a Boolean result. Let's start. So let's look at the less than operator. So this operator allows us to check if a value is smaller than another value. Now the next one is the greater than. So I'll explain this a little bit. So we are always checking if the value on the left hand side meets a criteria with the value on the right. So we always start with the left to the right, not from the right to the left. So now this one works for numerical values alone, the less than. We're trying to check if the value on the left is smaller than the value on the right. Now the greater than, we're trying to check if the value on the left is bigger than the value on the right. For less than or equal to, we're trying to check if the value on the left is less than or equal to the value on the right. Now before we go further, the less than or equal to I want to explain. Now you notice the or there, there's an or there. What this means is that if the value on the left is less than the value on the right, but not equal to the value on the right, according to the or logical operator that tells us that if we have at least one Boolean value, everything is true, this condition would still hold. So if a value on the left is less than the value on the right, but not equal to the value on the right, this comparison operator is going to be true. It would return back a true Boolean result. I hope that makes sense. And if the value on the left is equal to the value on the right, but not less than the value on the right, it will still return back a true Boolean result. I hope that makes sense. Now the next one, greater than or equal to. So this operator allows us to check if the value on the left is bigger than or equal to the value on the right. So it's still the same principle as this because we have the or there. So as long as one of the conditions is satisfied or has been satisfied, it's going to return back a true Boolean result. Then equivalent to. So you can see that we write it with a double equal to. So this operator allows us to check if a value is the same as another value. So we are simply trying to check if the value on the left is the same as the value on the right. That's what this is trying to say. Then not equivalent to. This operator allows us to check if a value is not the same as another value. So we're trying to check if the value on the left is not the same as the value on the right. So take note, not the same. So the context of what you are trying to do would determine the Boolean result that will be returned. For instance, if I'm trying to check if the value on the left is the same as the value on the right and it is not the same, I'm going to get a false Boolean result because I'm trying to check if they are equal, but they are not equal. Hope that makes sense. And for this one, the not equivalent to, if I'm trying to check if the value on the left is not the same as the value on the right and they are actually the same, I'm going to get a false Boolean result. I hope that makes sense. All right, so let's start with code. So the first thing we want to do is to check for equality. So you head over to your PyCharm and start. So I'll just clear this for the sake of my subscribers and start with this. So you create a variable called name, you assign it. So I would increase the screen size so that we can see what we are doing. I would assign it a value of Alex, and I'll come here and say print name equivalent to Alex. So I'm sure you know what this would print out from my explanation. This would print out true because I created a variable, I assigned it a value, and I'm trying to check if the value of that variable is the same as the value on the right. So I'm sure you know that this will print out true for you. I hope that makes sense. So, like I always give you, or like I always told you as a good practice, when you are done writing your code, you want to comment it out. Right, the next thing you want to look at is ignoring case when checking for equality. So I said this is when we forget to spell or write a value we are using to confirm equality properly. So I will still be making use of this variable. So like I said, name is equal to maybe David, and now come here and say print name is equivalent to David. So we all know that Python is case sensitive from our previous tutorials. I created a variable, I assigned it a value of David, but I'm trying to check if that value that I assigned to that variable, if it is equal to David with a small letter d. Now you will discover that this would give you false. Although they are the same name, they were not spelled the same way. Hope that makes sense. Now we can also check for equality. So we said that this is when we confirm that a value is not the same as another value. So you create a variable, assign it a value, and then you check if that value, or you check that that value is not the same. The value on the left is not the same as the value on the right. So I can create a variable and call it Adam, and come here and say print info is not equal to Jerry. So you can see that here I created a variable, I assigned it a value, and I'm now checking if the value on the left is not the same as the value on the right. Now this will give me true because they are not the same, because and that is what I'm trying to check for. So now looking at numerical comparisons, the same thing we just did for string values is the same thing we can do for numbers. So we said this is when we use comparison operators for numerical values. So you come here and can write your code. I just give a title numerical comparison. So I can create a variable, call it number is equal to 44. I can come here and say print number is equivalent to 44. Now this would give me true because I'm checking if they are equal, and they are actually equal. I created a variable called number, I assigned it a value of 44, and I checked if that value is the same as, if the value on the left is the same as the value on the right using our lingo. If you run your code, you will discover that you have that as the result. Alright, so let's look at checking multiple conditions. So we said this is when we create multiple Boolean values using comparison operators, and then we link them with one or more logical operator. One or more logical operator, not operators. So you create multiple Boolean values using comparison operators, and then you combine them together using either one or more logical operators. So now you can see that here I compared these two Boolean values together here, and sorry, I compared these two numerical values together. I was checking, or I checked if num_comp1 is less than num_comp2. As you can see, this value here is actually less than this value. Or let's just write it ourselves so that it can be the the concept can be able to can stick properly, and you can be able to understand it well, because there's nothing as writing code yourself. If I copy and paste it, you would not flow and you would not learn how to write code. So I'll create the variables from scratch. 54, I'll create another variable, assign it a value. 5, another variable, assign it a value. 70, another variable, assign it a value. Now I'll come here and I'll say print. I'll say num1 less than num2. As you can see, this is true. And I'll use the AND logical operator. Num3 less than or equal to num4. Now, according to our truth table, you can see that here I'm comparing two numerical values together. I'm checking if the value on the left is less than the value on the right here, which is true. It is less than the value on the right, and I'm also checking if the value on the left here is either less than or equal to the value on the right, and you will discover that this would also give me true. And if you can remember from the truth table, we said if we are comparing values together and everything is true using the AND logical operator, we are going to get a true result. So what we are just doing here is that we are trying to confirm if the truth table is correct. I'm trying to confirm that I'm not just spewing out things or fallacies. We are trying to confirm that I'm not teaching you fallacies here. I'm teaching you the right, correct thing. So you will discover that this will give you a true Boolean result. Now, what I can tell you to do is that from the assignment I will be giving to you, I might not give you in this video. I might release it in subsequent videos. But one of the assignments you would do on your own is just for you to confirm. It's not as if it's anything that will make you get better as a programmer, but it's imperative. Sorry, not imperative, optional. You can decide to confirm each of these values we got in the truth table. All those values we have here, false, 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 true, true, just to see if you apply your knowledge of, if you put it into code to see if you are going to get the exact same result here. You are trying to confirm if you will get the exact same result. So this is one I've done for you already. This is one that we have just done. You can see that here this would evaluate to true, this would evaluate to true, and comparing them together using the AND, of course they are both true, so that's why we had a true result. So I've just done one for you. This one I've done is equivalent to this part in the truth table. Is equivalent to me comparing the first row of the first two columns of my truth table to see if indeed I got the true Boolean result. And you can see we had that. So your assignment, although not mandatory but important, is to see how you can manipulate your code such that the second value being compared would be evaluated to false like this, and to see really if you would get a false result if you compare both values using the AND logical operator. And you can also do the same for the OR to see if you are going to get the respective Boolean values we have here. I said it's not mandatory. You understand? It's optional. So you can do what you want to do. All right, the next one is checking whether a value is in a list. So this is when we confirm if a value is contained in the list using the in logical operator. This gives us a Boolean result, either true or false. All right, so we are familiar with true and false. We want to see if we can really apply what we have learned. So I told you that the in logical operator is not used in the truth table, but we use it to check if an element is contained in a list. So I can create a list called contain and just pass a few numerical values. So this would be a numerical list. Now I can come here and say print. So I'll just say print 23 in contain. Now you can see here from our code, the value 23 is indeed in this list. It's at the 0 index. So this would give me a true Boolean result. As you can see, we have a true Boolean result. So I will comment only this out since I'm still going to make use of the list. Now the next one is to check whether a value is not in a list. So this is when we confirm that a value is not contained in a list using the not in logical operator. This gives a Boolean result of either true or false. Now, the only thing I did here was that I would just include the use of the not before the in. So I can come here and say print maybe 44 not in contain. Now as you can see here, this value 44 is not in this list, so this would give me true. It's only if 44 was here in the list and I was saying not in, only then would I get false, but I would get true because 44 really is not in the list. I hope that makes sense. Now, Boolean expressions. So these are true and false values that determine if a condition can be that determines if a condition can execute a program or not. So we have seen them. We have seen that all what we have been doing, we have either been getting true or false, like that as the result. Now, it might not shock you. You guys might be familiar with other programming languages, but you can also use these Boolean results that we have been getting as values. You can assign them as values of variables and you can use them to make sentences, just like how you assign a value to a variable, such as string values or numerical values. You can do the same with Boolean values as well. So what we are going to do, just comment this out since we are done with this, and then you can come here and write your code. So I can just come here and say Boolean values. So I'll just create variable, call it first, give it true, and create another variable, call it second, give it false. And I can come here and make a sentence. So I'll just say the result is, you can come here and say print what you said is is. So this will print out the result is true and what you said is false. So we are already familiar with f string, so I don't think I should go over that again. So you comment this out when you are done. All right, the next thing that we're going to be looking at here is if statements. So we needed to understand Boolean values. I hope with what I've done, you have a better understanding of Boolean values and results and how they come about, or rather how they are brought about. I'm sure we have a good foundation of Boolean values and Boolean results. Okay, so if we do, we can proceed to if statements. So I'll start. So this is a statement with a condition whose condition needs to be true before a program can be executed. The program below demonstrates this. So the program below demonstrates this. All right, so it's a statement that has a condition, and the condition has to be true before the program can be executed. It's different from conditional statements that we defined earlier. We said conditional statements are statements whose results are either true or false, and they determine whether a program would get executed or not. So conditional statement is a general definition. It's a more broader definition. Now, if statement is narrowing it down to the fact that we have a statement and that statement has a condition, and that condition needs to be true before a program can be executed within that statement. So it is narrowing it down to the fact that you have a statement, you have a condition, and the condition of that statement needs to be true before you can run a program. So we'll just start without further ado. You create, I just come here and say conditional. You can just create a variable, say name is equal to James. And you can come here and say if name is equivalent to James. You want to just come here and make a sentence with that. You can use your F string and say greetings the name. All right, so what we're simply doing here is pretty straightforward. That's why I had to talk about booleans previously.